Hi everyone, thank you for watching my previous video about creating IBCS-styled charts in Power BI using native matrix visual and SVG images. Thank you for all the likes, comments and shares. I'm happy that you have found the video interesting and useful, and today I'm going to continue the same topic. I will talk about creating IBCS-styled bar chart, small multiple, using the same matrix native visual and SVG chart generated by DAX measure. And this is the chart I'm going to talk about today. It's a column chart, small multiple, and this specific chart is about net profit in million of euros, absolute variance from location average. It means that we have net profit average for all the countries, and we are comparing net profit of each specific country with average net profit for all countries, and we're doing this by year from 2016 to 2024. Also, you can notice here that we have two periods, 2016, 2022, we have actual data, and for 2023, 24, we have a plan. There is no yet actual data for these years. And you can see this green column means that in 2016, net profit in Germany was 193 millions of euros above all countries' average. And we have a plus sign before the number because it's a variation, and the plus sign helps us understand that it's not absolute value, but it's just a variance between two absolute values. And in 2020, we see that Germany net profit is 23 millions below all countries' average. And also, you can see that columns for the years with no actual data, they not filled with the color, just outlined. It's for easier understanding where we have actual data and where we have just a plan. Later I will explain in more details how this chart is designed, but now I'm going to switch to relative view of this chart by clicking on this relative part of the slicer, and you can see that the chart looks different now, because now it shows not absolute variance between country net profit and average net profit, but it shows relative variance in percent. So we have for Germany in 2016, net profit is 71% above the average, and in 2020 it's 8% below the average. And both these views with absolute and relative variances created using the same DAX measure and using the single matrix visual. There is no any bookmarks here. It's not two different charts. It's one chart. So it won't be possible to replicate this chart using a column chart visual and small multiple option of that visual. So what I use it again, it's a matrix visual and the SVG chart generated by DAX measure. And again, in the following videos, I will explain more in details what is IBCS and why the chart looks exactly like this and not in a different way. But now I need to highlight that this narrow columns, or now they rather looks like pins with a pin head. Use it exactly to make it clearly visible that it's not absolute variance anymore. It's relative variance, and the values are in percents, not in millions of euros. So when we are switching between two different views, we don't need even to read any titles or comments or whatever. We just from how the bars or columns looks understand where we have absolute variance and where we have relative variance. Also, I need to add that the green or green blue color here means something is rather good. Net profit is above average. It's rather good indicator. And red means something is not so good. And net profit is below average. It's not necessarily something really bad because in the best case, we anyway have variation between countries, and there will be years and countries with net profit below average, and there will be years and countries with net profit above average. But it's something we need to look in case if it's really far below average. So it's highlighted using a red color. And also on this relative variance chart, we use this pinhead to highlight where we have actual data and where we have planned data. So if on the absolute view, it was about using filled columns with just outlined columns, on the relative view, it's about having black fillet pinheads and having outlined pinhead. So where the pinhead is outlined, it's just a plan, and where it's fillet, it's an actual data. Also, on this chart, you can see that we have years labels for the years only on the first chart, and on the following charts we have just these three lines that help us easier to see where we have first year, where we have last year, and where we have 2020, which is labeled on the first chart. So again, you don't really need to replicate the labels on every chart. It will just add more clutter. It's really easy to understand what is going on the following charts if you have the labels only on the first chart. And now I'm going to switch to the DAX code of the measurer inside of this visual, and I'm going to show the visual itself, how I started building it, and how it works that native matrix looks like this. So how I created the matrix? To create a matrix, I need two-dimension fields. I need to put something into the rows, and I need to put something into the columns of the matrix. But I have just a list of columns. Let me show you my country table. I added to my country table two columns, grid row column and grid column. And in these columns, I have numbers from 1 to 3. So I have all the combinations of 1 to 3 in one column and 1 to 3 in another column. So it gives me 9 countries, and I have 9 countries to display in the 9 cells, all possible intersections of 3 rows and 3 columns. In this case, it is hard-coded, but it can be generated dynamically in real-life applications. And now I'm opening the matrix, and you can see here that in the rows of the matrix, I have country green row field, and in the columns on the matrix, I have country grid column field. So this is what gives me 9 cells, and I have a measure here, SVG sales variations measure, which generates SVG image. And one SVG image generated by the measurer is one bar column chart for one country, which contains rectangles or columns. It contains text labels for the data. It contains text labels for the years, and it contains lines for the axis, lines for these 3 years, and this vertical line, which is just separation between actual data to the left of the line and planned data to the right of the line. The same DAX measure generates another view of this matrix, which is relative variance view. It just verifies what selected value is in the variance slicer. So variance slicer, let me show you which variance table. It's just a switch between absolute and relative values. So the slicer returns either absolute or relative word, and the measure verifies if absolute is selected value, then it generates absolute variance column chart, and if it's relative, then it generates relative variance chart, which looks like this a bit differently. In this case, SVG image includes rectangles for the pins or narrow bars columns, and it generates rectangles for the pin heads, and everything else is the same. We have text labels for the data, we have text label for the years, we have the lines for axes, years, and to divide actual data and planet data. So again, it's the same measure, and I will switch to DAX editor to show you what is inside of the measure. So this is the measure that generates SVG image for each country chart. Let me skip the comments on the top and start from explaining the variables. First variable is relative variance. It's just variable that checks what we have in the absolute or relative slicer, and if the selected value is relative, then its relative variance is true, and it later will be used to switch chart view from absolute to relative view. The following variables is just hard-coded colors used in the chart. So we have green color, but it's not pure RGB green, it's green-blue. So you can see the hex code here. We have red color, we have black color, and we have white color. White color is to fill the outlined columns. And then we have variables for the sizes. We have total width of the SVG image, we have total height of the SVG image, and we have header height and footer height values, which are for space above the columns and below the columns. The space above the columns used to put the country name, the space below the columns used to put labels for the years, and in this case, the values are hard-coded, but in real-life application, if you have more time to develop, you probably will want to make the visualization more responsive, and will want to replace these hard-coded values with some formulas for the calculation. The next thing is very important in regarding of IBCS guidance, because here we calculate column width. It's not good when column width in your visualization is based just on amount of space, how much space you have on the screen, and how many periods you have to display. For example, if you have just 1 year to display and your chart is wide, is really wide and takes the entire screen, then you will have a really wide column for this year. And then when you have more data for more years, the column will be more narrow every year because we get more and more years visible on the screen. And then when you have 2 years of data, you will have really narrow columns for each year. And this is not the best approach when you trust the software to calculate the column width. The best approach is to make the column width represent something meaningful about your data. In this case, we use column width, which is calculated as 2 2/3, which means we have 67% bits of the category for the column, and the rest of 1/3 is a white space between the columns. And for relative values, we have narrow pins that takes 10% of the space, and the rest 90% of the space is just white space between the pins. And in other IBCS styled charts, you will want use column widths to have different widths for years, quarters, and months. So you can easily see when you have different charts on the same screen. One chart is for years, another chart is for months, another chart is for quarters. You just can look into the column width and you will understand which chart for what without reading any text, titles, or comments. So you can use column width as a powerful tool to explain different your data, not just to be dependent on the default settings of Power BI or another tool. Another variable is the pinhead width multiplier, which means that my pinhead will be 3 times wider in comparison with the pin itself. Max column width is again it's related to what I was just talking. In this case, I just limited max column width with 5 or 30 pixels, depends of is it absolute or relative variance. But again, in real life application, when you have dynamically changing data, dynamically changing size of the visual, dynamically changing number of periods to display, you will want to put some more complicated formula here. I just wanted to make sure that with less coding it works with my data sample, but it's just a template for future development of the visual, so it can be replaced with more complicated formula. Then I have data label offset, which means that I have 5 pixels offset between the columns and data labels above or below the columns. Again, we can use some formula here instead of hard-coded value to make it dependent on font size. Also, the same is true for column width. We can make everything depend on font size. We can make some calculations here. But again, for faster development, I just use it hard-coded values. Lines are 0.3 pixels wide in the visualization. Font family is just a name of the font to use in the visualization. Title font size, period label font size, and the data label font size is just for the font size. Again, we can make them dynamically calculated for more responsive visual. And the next variable will be more complicated because we already reviewed the configuration section of the measurer, and the following is the data preparation and calculations. And I will switch back to the chart for a second to explain something. You can see on the chart that we have 9 periods or 9 columns. So we need to generate 9 rectangle objects in the SVG image. I'm switching back to the measure, and this is where the data preparation is started. I need to take all my years, and I need year name of, I renaming it to period here, and then I need to check is it actual or planet data, so I can format the columns differently, and I need a value of the variance, and it will be either relative or absolute variance. It depends on the slicer selection. So this variable generates a table with the data for all years in the visual. In the next variable, I just add in row number, just number in my rows from 1 to 9 instead of using years from 2016 to 2024. I just add in numbers from 1 to line for every column. So later I can use this number to calculate a position of the column on the axis. The next variable is to calculate what period is first on the chart, what period is last on the chart. It will be used for the date, for the year labels. It was period start, period end, and first one is for beginning of the planet period, so it will be 2023 in our case. And the next three variables is for the end year 2024, first year 2016, and the year in the middle, which is 2020. So here I'm just calculating the years for the labeling purpose. The next variable is to get the largest possible variance positive and largest possible variance negative. This will be required for scaling to understand how much space we have to display the columns within the image. We need to understand what is the largest and positive and the largest negative values for the largest red and largest green column. Count of periods is just total number of columns or years. Plot height, it calculates what part of the visual we use for the columns. It's just total height of the image without header height and footer height. Then we calculate column width. I already explained it, how I'm doing that and how we can improve this. And the next variable is the space between the columns. Again, we use two different ways to calculate column width and the space between columns. For absolute variance, column width is 2/3 of the category space, and the rest is the white space. And for the relative values, the column width is just 10%, and the rest, 90%, is the white space between the columns. And then we have this value range, which is the range between the largest negative value and largest positive value. So the range we need to display on the chart. And then I calculate a position of axis X line. It depends on max value of the positive column. So I just calculate this position of this line from the top of the chart. So it's the header height, and then how much space I need for the positive columns. And it will be position of zero line, and everything below the line will be negative column. The next variable is to generate data marks, which means we already start in generating SVG objects such as rectangles for the columns and text for the data labels. So we used the table with all the years and all the values we prepared earlier. And we calculate column height here just by dividing value by the range that we calculated earlier and multiplying by plot height. So we calculate column height, depends on available plot height and depends on the values. And then we calculate X position using these raw numbers that I mentioned earlier. So we just shift each column to the right using the column width and space between columns width and row number. The next variable is to get a color for column outline. So it's green or red, depends is it positive or negative value. Then we have color column fill. It also depends, is it actual data or planet data? For actual data, we use filled green. For planet data, we use just outlined columns in the case of absolute variance, and in the case of relative values, we make it differently. We use different fill color of pinhead. So these two variables to calculate the colors for the columns and for the pinhead. The next variable is for column position on the axis y. So again, we are starting from zero line, and it's either above zero line or below zero line. Sorry, if value is positive, then we need to go onto the column height back to the top. So it's the position of zero line minus column height. So we're starting driving the column from the top. And if it's a negative column, which is below zero line, we start in drawing it from the zero line, because it will go down below zero line, so it will be zero in this case. We start from zero line. Then it's period line position. It's for these three lines that we use it for the years labeled on the chart. Let me go back. It's for these three lines for 2016, 2020, 2004. We just calculating axis y position of the line to make sure it's starting right below the axis zero line plus some offset between the line and between the axis line and this vertical line. And in case we have negative columns, it's starting after some offset below the text label. So this is what we are calculating here in period line y position. And then we calculate data labels, axis y position. So this is about these data labels. They are either above positive columns or below negative columns. So this is what we need to calculate, and this variable is used for this calculation. And then we have a baseline for the data labels. Again, the data label will be either above the column or below the column. So it depends if value is positive or negative. I use different baseline, top or bottom. And the next variable is already generates a rectangle SVG object by itself. So this one is for pinhead rectangle, the black fillet or outlined pinhead rectangle. It will be this. So it's rectangle, X position of the rectangle, Y position of the rectangle width, rectangle height. Everything is based on the variables we already calculated. And pinhead fill color and stroke color. And this is generate the pinhead. Let me switch to the relative chart, and I will show you once again this black pinhead and this black outlined pinhead. This is what is generated by this variable. I'm going back to the variable. So it was the pinhead rectangle variable. The next variable is data rectangle. It's for absolute values columns. It's a bit more simpler than for the pinhead. The same approach. We have already pre-calculated position variables, column width, column height variable, color fill, and color outline variables. So we just generate rectangle object using existing values of the variable. Then the following variable is for the text labels. So we create the text object of the SVG image. Again, it's the same approach. We have X, Y position, we have font family, font size, and fill color and other attributes of the data label. What is important is this format for the value because again we need to add a plus sign before the positive values to highlight that these are variations, not an absolute value. The next variable is the period vertical line. It's for the vertical lines that I already showed you. I can go back and to do that once again. It's for this vertical line that creates a visual connection between the year labels and the rest of the elements on the chart. And once again, I'm going back to the text measure. And we have this period label where we generate one more text object for the year labels. And you can see that it's the same approach. It's a text object with everything else already pre-calculated earlier. But here I verify if period is in period start, period middle, or period end. Then I will generate this text object and display it. If period is different, not 2016, not 2020, and not 2024, I won't be generating this label. It will be empty string. Another variable is for the vertical line that divides actual and planet periods. It's a line object of the CSV image. And again, here I verify if period is the planet period start. So if it's 2023, first period is planet data, not actual data, then I will generate this line. Otherwise, it will be just empty string. And position is of this line is calculated to make sure it's between 2 years, between two pins, or between two columns. Because the lines for the years, they are in the middle of the pin or column, but this line needs to be between two columns or pins. And then I just return what was generated earlier. All the rectangle text and line objects, they are just joined together and returned by this variable. And the rest of the code is the declaration of all other elements that not related to specific date period. So we have SVG header declaration, which is just the same for all SVG images. We have opening SVG tag, which is again the same for all SVG images, and we have closing tag SVG, and then we have a text title variable where we generate a text object for the country name. It will be the title of our SVG chart. Then a variable for axis X line, so it's a line object. Again, here we are generating objects that need to be created only once for the chart, because earlier we were generating objects for every period or for every column on the chart. And the next variable, again, we just joining together all the elements of the SVG image. We have SVG declaration, we have opening tag, we have title of the chart, we have the data marks, which is a large variable. I explained it earlier. And we have axis X line, and we have closing tag for the SVG, and return SVG image. What is the important here? this DAX measure, we need to change data category for this SVG, for this DAX measure to image URL, or else it won't work. You won't see the image, the chart, you will see the SVG code in the cell, just a text. That's all. I believe it's a very interesting and useful topic. I will continue developing some interesting charts based on this approach. But again, in the following video, I'm going to focus also more on some theory of international business communication standards to explain why it works better when you design your charts using this approach. And again, it will be switching between some aspects of the theoretical aspects of the IBCS, and some issues of how we can generate these charts in Power BI using the NAP, using native visuals and SVG, what limitations we have, what issues we can override using some tricks and workaround, what we can't and probably need to ask Microsoft to fix something in the future to simplify for us our work, so we can create better charts with less of tricks and workarounds. We can focus on the quality of data visualization, not on tricks and workarounds to achieve some things. Again, it's already mind blowing what we can do using native visuals, and I'm very happy. And I think many of you also was very surprised that we can make something like this. And my previous video already got a lot of views. And thank you for being with me and watching my videos. Let me know in the comment what you think about this approach to generating charts. I mean, technically, what do you think about SVG images? And what do you think about IBCS? What do you want to know about IBCS? Thank you for watching the video, and see you next time. And don't forget, look into the description of this video. I will add a link to the Power BI file with the chart and with the DAX measure, and also I will post everything into my GitHub repository, so you can look deeply by yourself, and you can use what I created as a template for your own work.